The problem will be discussed is problem number 11, pumpkin straw. And we have 5 minutes for the reporter to prepare for the presentation. Oh, yeah. In the meantime, please write out your name. Please write out your names.另外2位是谁？另外2位是谁？不确定。他们应该有证。 The time is almost up. Reporter, please proceed your presentation.
And you have So okay, we are in group 11, and we are going to present the pumping straw. And our problem statement: a single water pump can be made using a straw shaped into a triangle and cut open at the vertex. When such a triangle is partially immersed in water with one of its vertices and rotate around its vertical axis, water may flow up through the strip. And investigate how the geometries and other relevant parameters affect the pumping speed. So we are going to focus on how the surface tension affects the rise of water in a section's height when pumping, and what implications does this have for designing the size and shape and section and pipe experiment. And going to focus on as a straw rotates in water, how do aerodynamic affect the pressure difference outside the tubes, and thus that the rate at which water is extended, and how does the centrifugal force limitations affect water during the straw rotation. So we are going to investigate the phenomenon and our experiment and data analysis and conclusions. So for our observations, upward intensely rotations, water began to flow upward through the straw. A bit slowly at first, the flow rate appeared to increase as the rotation speed was increased up to a certain point. Larger triangles seems to facilitate a greater volume of water being pumped, possibly due to a larger water capture area. However, there required more force to rotate at the same speed as a smaller triangle. A higher rotation speed, the centrifugal force appeared to counteract the upward movement of water, with the water being pushed outward more prevalent in dictating a limit to the efficiency gained from increasing rotation speed. And there are some possible variables. So like the rotation speed, and the rotation speed might change our result, because we know like rotation speed will affect the power of the things that the higher rotation speed to increase the water flow up the strip during the increasing the force. So I mean, if we increase the rotation speed and the force that the water push outside the central will be increasing too. So the water might be split out faster and further, and cut the size of the verticals. So the size of the diameter the strip was having will also affect it. So the bigger the strip and the smaller the strip also affected, because the volume that the water is inside up toward the strip will also affect it. An experimental equipment. We have like there's the steam straw and water and pump stick and water container and rotation mechanism. An experiment predictor. Use the straw to make an equilateral triangle. You make it in the triangle shape and attach the straw triangle to the rotation mechanism, and ensure that one vertex of the triangle is pointing towards the vertex will be submerged in waters. And submerge one vertex to the start triangle into the water. Start the rotation machine resumes at the predetermined speed. Use the stopwatch to measure the time it takes for a specific volume of water to pump out through the straw, and collect water in measuring cup or graduated cylinders, or record the volume of water collected at the time taken. It varies experimental conviction. And our experiment 1, the operation variables is the straw thickness, and the control variable, we need to control the straw and the material of the straw and the depth of the water and the rotation speed. And objective, to learn how does the straw thickness affect the water output efficiency. And this is our experiment 1 data. So you can see most of the data in the thin straw, they have like last minute to so they go last minute to stay in the air. So we can see they the output that they go outside the center is much less than the thicker straw. So the size of the incisions at the verticals affect the speed of the water. So the thicker straw make a faster speed to the water. So it makes a faster speed, they go further, so the time that we can see is increasing compared than the thin straw. And experiment 2. The operation variable is the speed of the rotation. So our control variable will be the same as the experiment 1. So our objective is to learn how does the speed of rotation affect the furthest that the water has gone. And experiment 2. So as we can see, the rotation speed. Okay, so we can see the rotation speed in the 80 RPMs is much. The average, we can see the average in here. The higher is the RPMs, the average second that the water at stake will be much less than the lower RPM. So the fastest speed of the rotation from a better efficiency of the output water. And theory 1. So I think an increase in the speed of the fluid occurs simultaneously with a decrease in the pressures or a decrease in the fluid and potential energy. When the straw triangle is rotated, the velocity of the water inside the straw changes, leading to variations in pressure that contribute to the water being dropped off through the straw. And this is our theory formula. So you can see 1/2 P times P squared plus the P GH plus P will be the constant, which the GS will be the gravity, and gravity will be affected, and the P will and the H will be the deepness. So the H will be the deepness. So H will also affect the water that have been pushed up, and the P will be the pressure that the liquid go. And also, and this our okay, and this our experiment will be looked like. So we will make the spur in triangle, and as we can see, the water will be pushed up, and the height of the this is H1 and this is the H2 that will do it in the theory. So for this theory, you can see the H1 and H2 is being inside, and so we can see when we are rotated, the water will be pushed up by very many different reasons. So if the water is being pushed up by the centers, and they will have the force like a triangle, and the force like triangle, the force like triangle will make the water being pushed up. And the centrifugal force. And the rotation of the strength triangle generates the centrifugal force, pushing the water outward to the side of the string. And this is our theorem 2 formula. So let's talk about like the mass of the water, and V will be the speed of the perimeter motions, the speed of the perimeter. And R will be the ratio of the circle. And W will be angular velocity. And the expect of phenomena. So we increase the diameter of the straw, and the efficiency of the water output will become higher. So the increase and the rotation speed of the section pipe will increase the amount of the water output. And so the conclusion, our conclusion will be the greater diameter of the straw will form faster speed of the output of water, and the faster speed of the rotations will form faster. Also, will form the faster speed of the water. Okay, thank you.
Okay, thank you. I'd like to have an opponent to ask questions.
So how do you define the thickness of the straw? Is that the radius of the straw? Is it?
Yes.
Okay. So as you stated in your first diagram, I think. So do you consider the centrifugal force to be the governing force of the whole experiment?
In which diagram? Yes.
You do. Okay. And so you do. As you said, you say the higher rotation speed is, and the rate of the water flow will increase. Am I right?
Yes.
Can just go on to the next stage.
Sure. Please.
Thanks.
Okay, opponent, please take the floor.
Okay, so greetings to honorable judges and fellow contestants. I'm the opponent of this stage, and the start with their. So here's a public statement, and they're focusing on how the sedimentation affects the rise of the water in such pipe when pumping, and how the aerodynamics affects the pressure difference outside tube, and thus the rate at which the water is ejected, and how the centrifugal force rotation affects water during stroke rotation. And here comes the summary of the reporter. So the theory they use is about the centrifugal force, which the student assumes to be the dominant force of the water, the pumping of the water, and they use Bernoulli's principle in their theory. And for their setup, they mention they use thin and thick strokes, and boosted water container and rotations machine. But they did not give a demonstration video or even a graphic drawing. And for their parameters, they discuss about the thickness of the stroke and the speed of rotation. And I think they do navigate the experiment procedure well, but there's some suggestion for us. So I think they do not have a clear explanation of the whole theory, and there's no demonstration video, and even there's not experience at all, so it is not easy for us to know how exactly the whole experiment works. And I would like to point out a point that we think is crucial. So the structure of the report. I think the report should consist with the demonstration video, and firstly we should explain how the phenomenon works. Then we go into the theory, and after theory, then we go to the experiments. And so here's the points of discussion. So I want to discuss about the force diagram because I think there's lots of factors they missed, and I would like to discuss about all the experience data as well because it wasn't so apparent to observe. And I would like to navigate the Bernoulli's principle with them. How do they exactly apply in their theory because it wasn't clear. And about the capillary folds, because as they stated, they changed the thickness of the stroke. So I think that could be a point of discussion. And the whole experience setup, because it's like the graphic demonstration, so I think that could be in discussion as well. And I would like to know how they calculate the exact value of the exact initial velocity and how do they define that. And that's it, things. And I would like to go on to the discussion part.
Okay, please proceed.
So, so first of all, can you maybe show me a force diagram up there? Because I would like to know how the all forces work in your experience.
Okay. So as we can see, we have like in triangle, the stroke make a triangle like this. So there is a, for me, the water will be here, and there will be a centrifugal force.
Yeah.
Yeah, do you agree?
Yeah, okay. I think we don't have to focus on this and this one. You can just state it as you can just throw me the water inside the straw because I don't think other will really affect.
Okay, so for me, I think the centrifugal force will pushing the water in this way, and there will have the force diagram will be like this. But as we can see, there will be a force that's going up, that's parallel to the stroke, and it affected to the water that will coming out.
Okay. So you divide it into two, right?
Yes.
But have you ever considered about like as the water going up or maybe here, maybe the water is in this point right here, there might be some viscosity inserting on the opposite direction. Do you concerned about this?
Yes, we do concern about this. Like there will be like some of the gravity or some of the force, the frictions.
Also, maybe because you did not clearly mention this one, and so in my personal opinion, I think that would be a kind of dreadful in this whole system. So, yeah. And so okay, so maybe we can move in on first. So as you mentioned, the aerodynamics. So how do you think the aerodynamic will affect the whole experiment here?
What do you mean the aerodynamic?
Because as you said, your focus is about the aerodynamic affecting the experience. Do you have some explanation of it?
So I mean,
Or maybe okay, we can go on to the next one. So as one of your parameters, you changes the radius of the stroke, right?
yes.
So do you agree with me? Is that so the point to discuss is about the capillary flows, because as the radius changes, the capillary flows by applying differ. So what do you think of it?
Yeah, I do think because like if we have like about the thickness, okay, so like we have like about thickness, I could say in here if the water, the area, the volume of the waters will affect it too, because if we like control the height of the water, okay, and the volume of water in the thickness strata will have the higher volume, yes. So if we have the higher volumes, then the waters that coast will affect in the surrounding will be much, and the strata that area of the strata that in touch the water also will affect it and increase the size of the water.
Okay, so how do you define it? Because you only said that the thin and thick strokes, and how do you define? Like, do you have the boundary of the radius about the definition of thin and thick? Like, how do you define thin and thick in your experience?
How you define the things and the thickness?
Yeah.
So the thickness of the things like my causes, because like in our variables there have like the air in here, and if the air have like the air pressure, because when we are like turning in the things, the air might be pushed out, and but if the thicker things that thicker the strata was, and the push out the air will be increasing.
Okay, so I mean it's about the air going out, and I think it will affect the force you mentioned going up to here about the force.
Yeah, and the air pressure will be not stable, and causing the water might also push out.
Okay, and then I'll proceed to so as you mentioned, you use Bernoulli principle here and for your theory calculation, but you didn't state it well. Like I did not observe well. Like, do you do the comparison between your theoretical value and your experience data? Did you do the comparison?
So for our experiment, this is our experiment about the rotation speed, and this about the thickness. And for our thickness, the comparison, yeah, I mean the comparison between.
So this is all experience data, right?
Yes.
So you didn't compare it with the theoretical value, or so maybe in your experience data, what do you think the trend is? Like, what does this explain? What does this tell us?
Okay, so this telling us that do you see the times? So in the time, this is the time that the water has been the time that the water is being flying through. So if like the time that the thicker straw is the time in the water in the thicker straw will fly further. So the time is is much higher than the thin straw. So this meaning the time that the water is flying through in touch the ground.
Okay, so this way, so you think thin straw can reach a greater pumping speed? Is that right?
I do think so.
Okay, then so about the rotation speed, would you like to go to the rotation speed daytime? So please tell me about the trend you observe.
So I think the rotation speed is affected because just like what I said in there, if the rotation speed is increasing, we can see the force, the centrifugal force is also increasing if we adding the speed, and it will cause the water want to be pushed up.
Okay, so meaning as the rotation speed goes up and the centrifugal force will
Increase too.
increase. And so I like so the second here is means the time as the water go from the bottom of here and to here. Is that right? So
Yes.
This is T time period. Okay. And so for in this case, as you say, the centrifugal force will increase as the rotation speed goes up, and so. But the centrifugal force goes like this, as you stated, and you divide it into two. And I would like to know, how do you define this one? Like, how do you divide it? How do you get the exact value of it?
Can you say it again? Because actually, this second is meaning the some of water is being pushed out by amount of the water that have been pushed out in time.
So meaning from here to here. Is it?
No, it's mean like if like there is the water, and if I push out amount of water, and how much time it will wait to push out amount of water.
Okay. So how do you think? The velocity here? If the okay, never mind. Let's proceed to another one. So, do you consider the depth of the straw in the water to affect the experiment?
Yes.
Then how do you think it affects?
So the depth of the water. So you mean like almost like the frictions?
No, I mean like how to what extent do you sink it into like I guess it might cause about something related to the buoyancy forces. Maybe you didn't take this one into consideration, do you?
Yes.
Okay, so maybe we can go on. So what do you think the friction affects? Do you
I just think the friction is affected because just like the angle also affected the friction, because as you can see, if the angle is being like higher, then the frictions might you can see just like in here.
Okay, I'm so do you think like as the water going up, it might go like this, right? So how do you think if the angle of the elevation angle changes, what do you think the velocity will be estimated correctly?
Angle change will affect it because the angle that the water is being pushed up, and the gravity that affects the distance will also affect it.
Okay, I think that's for our
Okay,
discussion.
that's the time up. Okay. Reviewer, please.
So we just discussed about the force diagram because I would like to know more about what I think about the force of pushing up the water, and we go into the investigation of their parameters, and because they were not showing the trends, how the experiment data what's the results and related to their hypothesis, and we clearly find out that, as they said, the thinner the straw is, it will create a better speed for a better pumping speed as the purpose statement requires. And I think there's still like It's their lack of comparison, and they do not. I cannot really tell what's the theory they mentioned and to their whole extreme. Okay, thanks.
Okay, thank you. I'd like to have a reviewer to ask questions, please.
First question, I want
Please.
to ask.
Hello? Mr.
Sorry.
I want to ask the reporter how do you define the pumping speed in your data?
Okay, so how can I define the pumping speed? So, define the pumping speed, we can see there is the 80 RPM and 90 RPM.
So that is if you have a cup of water and it is how many times you let it come out.
Yeah, the time
Okay,
is
thank
many.
you. And in your in what condition the straw can pump out the water more efficiently? You think?
So you think that what the pumping speed?
In what condition it will become the pumping speed will become more faster?
So I mean the pumping speed becomes faster.
Please give me a short answer.
Okay, can you like say it?
In what condition the pumping speed will become faster?
The pumping speed will become if we have a higher rotation speed.
Okay, and the question I want to ask both of the opponent and the reporter, and did you think what is the main factor to that the water can flow out through the straw?
I think the main one is for the centrifugal force exactly, and I think the defects there might be some some drag force affecting the density.
Okay, and what do you think?
Think about it.
What is the main factor to that the water can flow out through the straw?
Oh, I think the speed just affect the most, but the
So
size
is
of the
that, is that the centrifugal force to that the water can flow out through the straw?
yes.
Yes, okay, and did you think the viscosity of the water can help the water pump out the water more easily, or will that the pumping out situation become more slower?
So you mean the water, the height?
Viscosity.
Discuss.
Okay, thank you. And did you think that the water viscosity it can help the water pump out faster or slower?
No, I think it will be a bit slower because, as I mentioned, it will be a drag force.
Okay, and did you think that if the water level is lower than the straws in the curve, it can also pump out the water or not?
You mean like lower?
Yes, lower than the straws in the curve.
I'm not really sure because they're not doing consideration, but I think the height of the water is the shore sink in too.
So you think it might be sink in the water?
I think that would be a consideration that should be investigated.
Okay, and did you tell me?
If I didn't do it, I think the height of the water that is the deepness will also affect it. I mean the height of the
No, I mean if the water in the container the level is lower than the straws in that part, and it will pump out the water or not?
yeah.
Yes.
Okay, thank you. 2 minutes for the preparation. Okay, please give the presentation.
Hello everyone, my name is Du Shaoqi from Team 801, and the topic of my review today is topic number 11, pumping stroke. And here is the first statement. We will mainly focus on how will the geometry of the stroke affect the pumping speed and the relationship between the pumping speed and the rotating speed. And here is overview of the reporter's report. And for the theoretical model, they put the centrifugal force and Bernoulli's principles. And for the cons, they didn't consider about the friction and viscosity, and didn't consider the Coriolis force because the stroke will rotate. And for the experiment and the setup part, the reporter changed the rotating speed and the stroke diameter. And they have detail mentioned the experimental process. But we suggest the reporter can use the video to show the experimental phenomenon clearly. And they didn't have enough parameter to get an efficiency pumping situation. And for the data analysis part, they have the pumping speed and the parameters comparison. And for the cons, they didn't combine the experimental result and the theory. And lack of the data chart and the definition of the pumping speed only about a cup and the time of the water pumping out, how many it will be. Okay, and for the overview of the short question and speech, the opponent asked that the centrifugal force how will affect the result. And for the cons, the lack of the question about the data analysis and only asked one question about the centrifugal force, which the reporter has mentioned in the presentation. And for discussion, they discussed about the force diagram, viscosity, Bernoulli's principles, and capillary force, and the experimental result. And for the cons, they discussed the influence about the capillary action and point out the reporters that analyzes the viscosity. And the cons, they didn't mention that Bernoulli's principle can only be used in the ideal situation. And that is the key discussion point. And the opponent asked how will the diameter of the stroke pipe affect the pumping speed. And the reporter thinks that the diameter increase, the pumping amount will also be increased. But we think if the reporter control the immersed depth of the stroke and that the water resistance will become bigger, when the diameter becomes bigger and the rotating speed will decrease. So actually, I think the pumping speed maybe will decrease. And here is I asked the reporter about the pumping speed definition, and he said that they put the water in the cup and calculate the time of pumping out the whole water. And that is my question, and that is, did you think what is the main factor to let the water can flow out through the stroke? And the reporter and opponent also think that is the centrifugal force component first. But we think that is because the inlet part water pressure is lower than the outlet part water pressure, and the water will tend to flow from the higher pressure part to the lower pressure part. And that I asked, did you think the viscosity of the water can help the water pumping out faster or let it become slower? And the reporter can understand the question, and the opponent think it will be slower. And we think that in the first moment of the pumping process, the viscosity between the water in the stroke and the water in the container can let the water pump out more. But the viscosity between the wall of the stroke and the water will let the pumping speed become slower. And here is, I asked, did you think that if the water level in the container is lower than the container, the stroke can pump out the water or not? And the reporter think yes, and the opponent said that it should be investigated. And we think that yes, because when the stroke keeps rotating, so the airflow velocity above the water surface will increase and the pressure will decrease. So the water may flow up through the center and touch the stroke, and then the stroke will pump out the water. And thank you.
Okay, thank you. The concluding remark from the reporter, please.
So in our experiment, we have like two factors. One is mainly the thickness of the straw, and one is the spinning ratio, the speed ratio. So as we can see, I think that we need to add more factors that might cause the water that flipping up, because like some of the water, some of factors like the frictions, we didn't include it in the PPT, but we do understand the friction does affect the water pumping out. So I think in the PPT we can add some of the friction, but we just have like write some of the pressure, because the pressure that the air is pushing out, when the air is pushing out, the water will go up and the pressure in the water between waters, they have the space that causing the water is pumping out the straw. So we can also talk about it. And for the force diagram, we can write more about it to make the audience know like how does the force diagram from the centrifugal force affect to causing the water is pumping out. Thank you.
Okay, thank you. I'd like to invite some questions from viewers. Okay, maybe I can ask first. The reporter mentioned that their theoretical model is centrifugal force and also Bernoulli principles.
Yes.
I'd like to start from opponent. Do you agree or you don't agree? And please give it a reason. Then I will go for the reviewer, then to the reporter.
Okay, so from their theoretical model, I do not really agree because I think there's so many factors that are not concerned, so that wouldn't be the proper.
So you think it's not appropriate to use these two theories?
Like there's so many things that are missed.
Okay, how about reviewer?
I think they use the centrifugal force because that is equal to the mr omega first. So that it means when the rotating speed increases, the pumping speed will also increase. And I think that is related. It sticks to their experimental results. But they put the Bernoulli's principle, and I think that will just can use in the ideal situation. If they want to use that, they need to consider the viscosity of the water or the friction of the water. So I think that cannot be used in this experiment.
Okay, how about reporter?
You say one factor is like centrifugal force and.
Bernoulli principle.
Okay, so for me, I think that Bernoulli's centrifugal force affect the Bernoulli because I mean, if the centrifugal force like is increasing, as we can say, the water is being pushed out, and there will have like two Bernoulli frictions is happening. One is the air to the water, and one is the water inside the container, and one is the water inside the strip. So when if like the force is like increasing, so we can say the Bernoulli force will happen in two sides will also increasing.
Okay. Can you draw a diagram regarding to the centrifugal force in the bottom and on top? Which one is larger? Can you also draw it? Can you also draw it? Please. Can you draw the centrifugal force of the tube
In what stage?
when it rotates? Okay, thank you. Thank you very much. Thank you. Any more questions? Okay, please.
Change the thickness of the straw, right?
Yes.
So what's permitted if you want to examine by that changing the thickness of
So you think like what will be changing if like
what's permitted in your model? Can you explain that one?
so we know like there have many factors will affect it. So like the friction also will affect it. So the friction, as we can say, the thickness of the friction. So like the around, if I didn't change the height of the water, and the if the thickness is increasing, then the area that in touch, the water in touch the strut will also increase it. And the area increases, and the friction might also affect it.
So when you change the thickness, you change the area.
That in touch the water, and it will affect the speed when this is pumping out.
Okay. Do you agree with this point?
About proposals.
No, about the friction.
I think maybe I consider
Okay.
Wait, so can I clarify one thing is centrifugal force is not a real force, like it's a force in theory. So that's why I'm drawing like in two directions. So,
I think we understand that, right?
Okay.
Okay, thank you. Okay, Juros, please show the score for the report. 5, 3, 7, 4, and 4. Okay, the score for the opponent. 7, 5, 5, 6, and 6. And the score for the reviewer, 7, 5, 6, 8, and 7. Okay, thank you very much. Thank you. We take a